Hello, everybody, and welcome back to Vector Lab. Today, we're going to discuss how you can use GenAI and specifically AI query on Databricks to get a better understanding on your data. The dataset, it has to do with healthcare, and it is about clinical data, like patients to doctors conversations, but the technique and the patterns apply to any sector, really. So let's go.
Let's do it.
Okay, so let's define a little bit the business problem. So in case you are working on the healthcare industry, you should probably have a lot of unstructured data, and this can be data for transcripts, doctor notes, any audio conversations between patients, doctors, and etc. So this is the data we're gonna work with today. And the challenge we're facing is that given the unstructured nature of this data, it's difficult to search, find the right information you want. They are not really structured, so you cannot do analytics and dashboards on it. And then also it's really slow to manually go tag different things and extract information that you want from this kind of data set. What we're gonna try to do in this demo is we're gonna bring the data in the right format to enable semantic search. And we're also gonna create, specific entities out of the data through GenAI. All of these to allow to accelerate the clinical insights and make sure we enforce and ensure compliance by masking patient names and PII information. And also we can bring to life all of these kind of use case with GenAI into an app in this case.
I love that we're going to show how to mask PII because I think in the healthcare sector, it's one of the number one questions that we get from customers.
We're going to see how you can do it in one line of code. So I hope people can take this and apply it. So the first thing, we're going to have 4 or 5 steps in this demo. But first thing is we're going to have our text data. Then we're going to create like this SOP notes. This is a specific format that usually doctors summarize the patient's transcripts. So that is going to be the first thing, how we can extract the information we want to bring the data into this specific format. The next one is we are going to extract information mentioned in the text about patient kind of behaviors. For example, if they're smoking, if they're active, all of these things that may have an impact into their health. The last one is we're going to understand the sentiment of this conversation. Is the person anxious? Is the positive conversation? Or how is the feeling in the conversation? We can also translate all of these to different languages. So in case you want to share this data with different regions and you want to play in the multi-language setting, we can also do that. And last but not least is for each patient, we are going to perform similarity search against similar cases for other patients. And that can help, for example, if you want to find if you are a doctor and you want to find similar cases of the case you have at hand and you don't know how to handle it, you want to see what other doctors recommended or what medication they provided. We can do that with semantic search and similarity search. And at the end, we're going to show you how you can, out of all of this information, build kind of a quick RAG application through AgentBricks. So that is the use case for today.
Awesome.
Amazing. So let's go to our code. It's actually it's a lot of things, but it's pretty easy to do. Okay, so all the data we're gonna go through, they are synthetically generated. And in this repo, there are 2 scripts in the beginning that helps you set up all the data set. First, setting up all the transcripts, and then set up all the different metadata things that we need. But after having done the synthetic generation of the data, you are going to be in this space where you have synthetic audio transcripts. The data look like this. So you have like a patient ID, name, when they visited, what is the doctor name, what kind of department this problem is associated with, and the audio transcript from this case. Okay, and this is the data set we're going to start with. All of the pre-processing we're going to do on how to transform this synthetic audio data transcript to structure SOAP note and all the different things we described in the beginning, we're going to do only with AI query. So we're going to show you how AI query, how powerful AI query is. So let's see. We are going to have the healthcare synthetic audio transcript dataset that we saw before. And what we're going to do is we're going to hit AI query through kind of the PySpark interface of this. And we're going to say, create a new column called SOAP node. And the only thing you have to give is pass the model. In our case is the Azure OpenAI model, plus the prompt we want to do. We're saying here, you're a clinical assistant, take this audio transcript and move it or transform it into a SOAP node, like subject, objective, assessment, and plan.
So just for As a quick reminder for those who don't know what AI query is it just like a SQL way to query an LLM and abstracting all the complexity of doing that?
Yeah, very good point. So AI query can be used with SQL or with PySpark as well, as we saw in here. But behind the scenes, it's kind of a completely managed service. So you only define the model and the task at this case. And we take away from you kind of the compute requirements, the scaling of these. The best application of AI query is for batch workloads, as we say, when you want to apply the model in multiple rows in a data set as quickly as possible. So in this case, if you think of our table, we have kind of millions and millions of transcripts. We don't really need a real-time processing of this. We're gonna apply this sub-generation as a feature engineering process once in the whole data set. Yeah, that is it.
Awesome. Yeah.
So instead of one by one or sequentially pushing the rows to the model, you do that all in a batch.
Got it.
Amazing. So by hitting this, what we do is we take the transcript really that we had before, the audio transcript, and here is the sub-generated output. So it really hit the LLM with this specific prompt and said, okay, this is the subject, this is the objective, this is the assessment, and this is the diagnostic plan. And that is the pattern that we're going to follow, right? So this is the first thing, format the audio transcript, summarize it in a sense, in a format that doctors want to work with. The next step is, apart from the fact that we want to summarize the audio transcript, we may want to extract specific entities from the transcript, as we said before, things that the patient may be doing and can affect their health, smoking, alcohol, diet, etc. In order to do that, we're going to use AI query with structured output. So we are going to tell AI query, take this text, take this model and this specific prompt, but I want you to find in this text specific entities and extract it for me. Specifically, it's an entity extraction problem.
Yeah, makes sense. And so how do you define that?
So this is the schema I want to tell AI query to follow, right? I'm saying, okay, this is the schema, the output I want as the output of this job for each row. So for each row, I want you to go follow this schema, and I want you the smoking status, alcohol use, blah, 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 right? And I'm saying all of this, I want you to return it. And all of these columns are required in this case. So how do I do that? Is I'm going back to my table. I'm saying, okay, AI query, given the model we have defined above, take the prompt plus the audio transcript, because we have to pass the audio transcript for each row. This is per row operation. And follow this response format that we have defined here. I believe the most complicated thing here is to define this response format. If you do that, nothing else is complicated. So you execute this job, and what you get out of this is, again, you have your audio transcript, SOAP node that we created before, but now you have this JSON for each row extracting things that appear in the text. Now, one challenge that you may find with this, in this way of extracting information, is the fact that we're saying to the model, we really said that I want you to go and extract any smoking status, but we never defined exactly what can it mean, can it have specific fields? And what this means is that the model went and extracted, for example, here it says medication adherence not mentioned, medication currently being managed with medication. Here, like it came up with whatever it felt covers this specific field for me. So if we want to use this kind of fields later on for a dashboard, for example, these fields can be very unequal between each other, right? So uneven, and
because it's not standardized, the responses, because you didn't give a list of options to pick out.
Exactly. Bravo, that is exactly the word, standardized. So it can be anything. You haven't standardized the answers for which the LLM cannot tag a specific row with. Yeah. So the next iteration we're going to do is actually standardize that. So we can come here, and for each of these entities we want to extract, we'll say specific standard outputs, specific categories that the LLM needs to go and match each row with. And that will allow us then to use them as filters or as categories based on which we can do specific feature engineering and all of these things, right? Because are more standardized at this point. So we go update a little bit the JSON schema, and we hit the same thing. We just change the response schema at this point. And the output we get from this is much better. So for each of these extracted outputs, the things, the categories can be only anything that was described here. So if you see now, everything is much more standardized. So now I can use this as a filter. I can use it as a feature. It's much more clean in this case. Does this make sense?
I mean, what I love is that, I don't know about you, but every time I go to the doctor, they do take the time to ask questions and then write them down, on their laptop. And if you have that, this means I could just have a conversation and not waste time as a doctor to write down what the patient is saying, because I know that the
Because you have
transcript
it.
is going to be taken care of afterwards. So I could just have a
Exactly.
conversation. Are you smoking? That's very
Exactly.
cool.
Everything is tagged for you. Amazing. And so this is kind of the structured schema enforcement with AI query. The next thing we can do is in this AI query kind of umbrella, there are many functions. It can be the sentiment classification. It can be the masking. It can be some the specific classification things that you can do. But these are even more abstracted than AI query. So let's come here and say, okay, I want you to classify this text, as we say, based on if it was a routine, urgent, or emergency kind of appointment. So we're not using AI query, if you see, we're using this AI classify. And the difference between this AI classify and the other one above is, what is it?
I guess AI classify is best for classification tests.
Yes.
Well, yes.
Yeah, and also it's more abstracted in the sense that it doesn't give you the option to choose the model. Before, if you remember, in the AI query, you were passing the model as a parameter. So you have the option to choose which LLM you want to use for this task, as well as you are passing the prompt. Now, all of this is abstracted for you, and it just knows, because it's a classify function, that it has to perform classification. And the only thing you need to provide is the type of classes that are being expected as an output.
So we don't know which model is being used under the hood?
No. So this is abstracted. And this is one of the AI query umbrella functions, as well as the masked. So the mask, we're using it to mask PII information in the text that we want to not be seen from when we are presenting this information. So in this case, for example, I'm saying go to the audio transcript and abstract anything that has to do with the person and the location. And that is the mask. You can go and mask anything, really. It's just gonna, we'll see how it looks like. So now we can perform, in this case, we can perform multiple AI queries in one operation, right? So I have split now my script in many different steps so that you can follow, but it could be just one big operation, right? I can do with column, with column, with column. And this can be my end-to-end feature engineering process from text to manipulating the text into a summary, plus creating on all my features that I need for the project. And that is the beauty with AI query. We kind of think of it as the new way of doing ETL. And now you also have the way to apply specific budget policies in this kind of job, if you think it as a job, so that you can have an idea of controlling the cost of a job.
Got it.
So as an output of this, we get, this is the structural output, the sentiment. Now, visit sentiment is a little bit not the right title, but what we meant is how, kind of how emergency appointment was this. And the masked output, it just changes this with the masked every time it's so like a patient name or any location. So in that way, it masks any PII information you would have seen inside. Okay, so we did SOAP, transformation of text. We did sentiment and sentiment classification, masking of things, as well as extracting on information from the text. Now, the last thing I want to show you is how you can use translation. AI Translate is another AI function that can do translation to a couple of languages. And in this case, we're going to do Spanish. So again, it's an abstracted function. The only thing you need is the column you want to translate and the language to which you want to translate. And so if I go here, you can see that it translated everything to Spanish, my notes. Yeah? So all of these, think of it as next feature generation steps that could be part of one process. Any questions?
No questions.
Clear? Amazing. And so we write our table. And the last thing I want to show you on this front is the fact that it may be interesting for each of these patient records to find the 3 top similar cases for to their case. So how can we use vector sets with AI query? So let me zoom out a little bit to find my code here.
It's so interesting because we've come such a long way. Remember the time when you had to prepare your data set to do ML on top, and
Yeah,
now use GenAI to
just
prepare
all the
your
data.
data set and make and clean it, and as you say, do ETL,
Yeah.
which is crazy when you think what we were doing just a few years back. Things have changed so much.
I call this equity feature engineering reinvented. Amazing. So for the vector search part, the only thing you have to do is have some idea of which models and catalogs you're going to use. We are going to create the index through the API. You can also do it through the UI. And we're going to say which column we are going to index. In this case, we're going to index the audio transcript. Nothing different here. We're just indexing this column, passing all the other columns as metadata, and
Love
we
it.
have an index are alive for us. The other thing that is interesting is how we can use this now index with AI query to find these similarity cases for each row. So what you can do here is you can select your audio transcript, and then what you can do is hit this vector search, which behind the scenes performs similarity search for each row. For each row in the audio transcript presents the top two similar rows. Yeah. So what is the result of this is that if I am Adam Jones and this is my original audio transcript, here you can see that it returned this one. Ooh. Okay, so the original audio transcript is Adam Jones, and Adam Jones' case was very similar to Gabriela and Natalie. If you see what that I want to say, like I am exploded my dataset and applying for each case the most similar cases to it. Yeah,
Got
and
it. So basically you looked for patients that had similar symptoms and it returns the audio transcript
yeah.
of those patients. So then you need to go and look for the enriched of those patients to see, for example, what medicine was given or something like that.
Exactly. That is the idea of this. Exactly. And on that front, I'm finishing like the feature engineering setup of the solution. But from that point onwards, where we have all of these features created for all our transcripts, now what we can do is create a RAG application around it, right? So there are many ways to do this. In this case, we're going to show you AgentBricks knowledge-based assistant that because we've never shown it in the channel, I think, right? We've shown it how to create the vector search on your own, but we haven't shown this style on AgentBricks. So I'll show you how the setup you have to do, but we have it ready so that we test it. So you come here, knowledge assistant, you give it a name, really. You give a description of what this agent is going to be, and then you just point it to your location. You can point either to files or to an existing index.
The description, is it so that LLMs know what it's about, or is it just for your teammates to know?
This is for the teammates, the
Okay.
content that we're going to describe here. Also, this passes into kind of the prompt instructions. What is this app about? Like the system prompt, if you think you are a helpful HR assistant, la la la. Yeah.
Got it.
So you pass here your index. In this case, we have created already our index that we built before on the notebook, if you remember. It's the same thing. You choose the column. This is the column where if you perform similarity search, you want to have access to the raw document that this chunk of the text was part of. So this is the column where you point to the actual PDF file or any column that points to the PDF file that had this specific chunk. And also you choose the column that the text column, like the indexed, not the index column in this case, because the index column is here. It just knows where is my actual text. It goes and just fetches which is the index column we have already pre-indexed. And then you give some idea of, okay, this is an indexed data set for all audio transcripts between patients and doctors.
Sorry, just a quick question. So just the definition of the knowledge assistant. So it's an agent basically that is where you provide it a vector index and then it will know to look into this index.
Bravo. Okay.
To answer questions that you ask. Is that what it is about?
Explain. So when we say knowledge assistant, at the end of the day, you're going to get a full end-to-end model, an agent, a chain, if you think it like that, where behind the scenes we have the index and an LLM who takes the user question, performs similarity search, returns the things to the LLM, and gives us a nice output. So all of this is knowledge assistant. Behind the scenes, it's going to do a lot of chunking, tuning, and etc. In our case, we have already the data indexed, but if you have parsed files, it's going to go parse the files, perform chunking, tune this chunking, like it's going to do all of these things behind the scenes.
So you
For
could
you.
give it the raw files and then
Yeah.
it builds the whole RAG pipeline for you out of the box.
Yes.
Got
Where
it.
in our case, because we already have the
Yeah,
index, we
in our
just have
case, we did the work, but you could
yeah,
technically not do it. Perfect. Sounds
exactly.
good.
Amazing. And then you do create agent, and then it's going to take some time to run. So I have it already done. So this is the same index, the same data set we said before. Nothing changes. The other thing you can do, by the way, is you can have multiple indexes and into this one app, if this is interesting, if you have a use case for it. But after it has done that, you can come here and interact with it and say, sorry, rendezvous, appointment, I don't know.
Appointment, yeah.
Yeah.
Rendezvous.
So it goes and behind the scene hits this this knowledge base for us. Now, one thing that you need to understand is out of this process, you have a wrapped artifact, right? So if I go and zoom into this behind the scenes has the model, the chain, the index, all of it wrapped together in one place. Yeah. So this is my endpoint really. And so I cannot go in and see what exactly is happening. It's kind of an abstracted artifact that I can just ping and use as an API or add it in a web app. But like the model, the tuning, what happened behind the scenes, it's kind of not open at this point in time. Yeah.
So just if I see that the responses are not what they should be, the problem is that then I cannot go and debug the RAG app. So probably it's great for people who are not very technical. Maybe more technical folks will want to build that themselves rather than
Yes.
out of the box.
Very good point. So if you want to have full control on what happened behind the scenes on the agent, how the agent propagates information, where it's keeping the memory, I don't know, any caching, any of these things, you don't have control over it at this point. So probably this is not the right solution for you. If you are anyone else who just wants had all the components ready and just wants to wrap it and serve it, this is exactly what this does. You have an artifact at the end of the day as an API.
Or if you're technical, but you have so many requests from so many different teams to build
Exactly.
RAG apps that then you just can spin that up very quickly to serve it to, whoever needs it. That's also a very good solution, I imagine.
Yes.
Very cool.
So here it's the output. Like it says, okay, some of the most common neurology appointments include this and this and this, and this pings to the actual, in our case, this is the audio transcript that referred
Yeah.
to this neurology appointment. Yeah, so now if you have this, you can open it in the playground and hit it. You can put it into a web app. You just have an endpoint up and running for you that you can ping from anywhere else. The interesting thing with this one that you can do is improve the quality of this. So back to your question that you said, if you find it not working well, you cannot go into the chain to debug it, but you can start giving it instructions and more examples for it to learn on its own. So that you can do, you can open a label session, and let's say if we say, okay, what are the top role appointments? So we can add it as a labeling session. And this means that we can start the labeling session. We can give this to our SMEs to play with the app. So think of it now, me being the SME, I'm getting access to this app and I need to check how good or bad the responses for the specific question are. Yeah. So
So
generating
you're
this.
doing evals, and then I imagine so that gets logged, and so you just get a nice eval data set that you
Yeah,
could use
it
afterwards.
gets logged and then it's fed into the process of retuning this knowledge assistant. Yeah.
Oh, so that can be done also automatically for you.
Yes. You add it into your evaluation dataset and then you can update your agent based on this. And so you can create a first iteration, judge it, collect some feedback. You can add specific guidelines, etc., or you can just collect feedback. Please provide the correct answer. say, I don't know, whatever. You can say this was correct or whatever. And then you save. Let's do it. Okay, maybe we can say that this was correct in this case. Well, save. This save? Feedback? Okay. Then you can go back to your agent and see one active question. And then you can say merge. You can merge these outputs into your evaluation question. You have here one record, right?
Got it.
And then what you can do is you can come here and update the agent again. And
Mm,
that is going to take into account all of these things that we have collected.
very nice.
Yeah. And so kind of in this way, you close the loop with human in the loop, getting some feedback, testing it with real users, and then putting it back into the process. Yeah?
Yeah.
Amazing. So that's it.
Great. Thanks, Maria.
Thank you.